Don MACHHOLZ, and you're listening to Looking Up with Don. This is the Looking Up with Don podcast, episode number 55 for the week of January 20th, 2021. The related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. What's up in the sky this week? As our week begins on Wednesday, January 20th, the moon is first quarter, half full in our evening sky. By the end of the week, Tuesday, January 26th, the moon is big and bright in the evening sky. 2 days after that, on January 28th, the moon will be full. On Wednesday, January 20th, the moon will pass just south of the bright planet Mars and the fainter planet Uranus. Last week's podcast 54, Map 3, is a close-up map of both Mars and Uranus as they pass by each other. With Jupiter and Saturn so close to the sun in the evening sky that they will be difficult to see, the planet Mercury alone hangs low in the southwest sky each evening. It sets about an hour or slightly more after the sun sets. If you see a bright star-like object low in the southwest, nearly an hour after sunset, that is Mercury. You should be able to follow it for the next 2 weeks. Saturn goes behind the sun on Sunday, January 24th, as seen from the Earth. It technically moves from our evening sky to our morning sky, but you are unlikely to see it in the morning sky for about another month. If you look at the current images from the SOHO spacecraft this week, you might see it pass behind the sun. The morning sky is still moonless, and if you're itching to see all those springtime galaxies, they start rising around 10 p.m. Wait until moonset, then go after them. Will you be able to see the International Space Station this week, which for our purposes begins Wednesday, January 20th through Tuesday, January 26th? It all depends upon your location. The ISS appears as a bright, slow-moving star going across the sky with several minutes of visibility. It is the brightest satellite in the sky. This week we have 7 zones. All you need to know is your latitude. From north latitude 65 degrees in north, you won't see the International Space Station this week, nor for several more weeks. But you probably do have the northern lights to entertain you. Between 38 and 65 degrees north, and many listening to this podcast live between 38 and 56 degrees north, you can see the ISS in your evening sky sometimes twice per night. Between 32 and 38 degrees north, the International Space Station will be in your evening sky too, but only for the first 2 or 3 nights of this week. From 5 degrees south through 32 degrees north, the International Space Station will not be visible at all this week. From 20 degrees to 5 degrees south, the ISS will be in your morning sky, but only for the first few mornings of the week. From 40 to 20 degrees south, the ISS will be in your morning sky all week, sometimes twice each morning. And south of 40 degrees south, the ISS will not be in your sky at all. To determine where it will be visible to you, go to the website heavens-above.com and enter your location, then click on ISS. I talked last week about the new comet C2021A1 Leonard. We do not know how bright it will get, but we do know the orbit very well and where we can see it. Comet 2021A1 Leonard will be closest to the Sun next January 3rd, 2022 at 0.61 astronomical units, slightly closer to the Sun than the planet Venus. It will be in the morning sky, northern hemisphere. It crosses the equator headed south on December 12th, then passes 17 degrees north of the Sun on December 13th. And so for about 2 days it will be in both your morning and evening sky. After December 13th it will be in the evening sky only, getting farther from us as it continues closing in on the Sun. Again, time will tell how bright it will get, and we will continue to monitor this comet throughout this year as it comes in. It's presently far from the Sun and at a faint magnitude 17. Last week I also discussed the second comet of the year, a Neowise one, C2021A2. It's presently in the southern sky near opposition, and the moon will interfere with some observations this week and into next week. Next week, I'll start posting positions for this comet. Comet 141P MACHHOLZ 2 is moving 2 degrees per day in our evening sky, setting near midnight. It is still magnitude 10 to 11, but it will be dimming soon. This week, it reaches its closest point to the Earth, 0.53 astronomical units, which translate to 49 million miles or 79 million kilometers. This is about 160 times farther away from us than is the moon. Photos of this comet are posted on my website. The moon is now in the evening sky, so the comet will be difficult to see until next week, when the moon will enter the morning sky. If you still want to try for it this week, a map showing the positions for both comets 88P Howell and 141 MACHHOLZ 2 can be found on my website, Podcast 54, Map 4. This week, our focus is on the moon, now in our evening sky. Let's take a look at one of the most famous craters on the near side of the moon, the crater Copernicus. The sun rises on this crater on Friday, January 22nd. So, prior to this Friday, the crater will be on the dark side of the terminator, the line separating the light and dark portion of the moon, so you won't be able to see it. A moon map and the crater are identified on Podcast 55, Map 3. The moon phase on that map is set for January 23rd, 2021. Copernicus, a crater named after the astronomer, is one of the younger large impact craters on the moon, and is believed to be less than 1 billion years old. The crater is 58 miles, that's 93 kilometers across. Compare that size to things you know here on Earth. 58 miles or 93 kilometers. You can fit almost any city and most counties into the crater. Some countries could fit into the crater Copernicus. This is one lunar feature which looks much different at sunrise or sunset than it does when the sun is at high noon, such as near full moon. This week, the sun is rising on Copernicus, and we have a lot of contrast. When the moon is full, Copernicus also stands out, but more because of its short ray system. The crater is about 2.4 miles, that's 3.8 kilometers deep, from the rim down to the floor, and the path is terraced. The central peaks, and there are 3 of them, stand about 2,600 feet or 800 meters above the crater's floor. You might ask, how did these central peaks get there? The theory is that it was a rebound of deep-seated rocks after the impact. At one point, NASA was considering sending an Apollo mission to land in the crater, north of the central peaks. But that was not to be, as we ran out of Apollo missions. The Apollo 12 astronauts, besides making a pinpoint landing near Surveyor 3, also landed on one of the rays of material thrown out from the impact of Copernicus. The samples they brought back were dated to be 800 million years old, which is one indication of when the crater was formed. Try looking for Copernicus with the unaided eye. Try it this week, and then once again when the moon is full early next week. Through binoculars, look at Copernicus. It should be easy to find. Look to the area around the crater. To the north and east, the surface is rough. It is much more smooth south of Copernicus. Through a telescope, crank up the magnification and let's see what we have. First, look for the terraced crater walls. Then look at those 3 central peaks. Refer to Podcast 55, Map 3, for these and the remaining objects. To the west, away from the terminator, you may see strings of small craters. Now we're going to head south of Copernicus and look for a string of 4 craters, actually 5. Refer to the map. Less than 1 crater width south of Copernicus is a tiny feature called Fauth, spelled F-A-U-T-H. And it is made up of 2 small craters, Fauth and Fauth A. There are also a lot of smaller craters labeled Fauth B through Fauth H. Go to the internet for a very detailed map of all those Fauth craters. The main crater is 7 miles, that's 12 kilometers across. Your city could probably fit inside this crater. Below that, and before you get to the next major crater, we find a small ghost of a crater named Reinhardt B. It measures 15 miles, that's 24 kilometers across. Right next to that is a real crater, Reinhardt. It's about 29 miles, that's 49 kilometers across. It is half the diameter of Copernicus, and its walls are 1.8 miles high, which is 3,300 meters high. Our final crater is further south. It is named Landsberg, and what a great-looking crater this one is. It's almost the same diameter as Reinhold. Landsberg is 24 miles or 41 kilometers across, and this one has a central peak. The walls are nearly as high as Reinhold's. Before you leave this area, go back to Copernicus and head towards the terminator and to the north of the crater. This whole area has some rough terrain. That's the end of this week's guided tour of the moon. But don't stop now. Spend a few more minutes looking over the moon. Time spent looking at the moon is never wasted time. To recap this podcast for this coming week, The moon is big and bright in our evening sky, and this week we're going to look at it, especially the crater named Copernicus. Mercury is low in our southwest sky after sunset. You have been listening to Looking Up with Don, podcast episode number 55 for January 20th, 2021. I'm Don MACHHOLZ. Once again, the related website for this podcast is donmachholz.com. That is spelled DONMACHHOLZ.com. 2 H's. You can contact me at dontheastronomer@gmail.com. Once again, that is one word, dontheastronomer@gmail.com. God willing and pod willing, I'll be back next week for another episode of Looking Up with Don. We'll discuss what's up in the sky. I'll have new things for us to observe. And in a podcast you will never forget, I'll talk about cats. Yes, cats, kittens, felines. And it is related to astronomy. All that and more. Thank you for listening. See the sky this week. I'll see you next week.